Section 2.7. And I'm going to list some steps over here on the right. And for all of this, we're saying that that our function f of x is n of x over d of x. So for our numerator and denominator. Our tools, the things that we're going to want to find and put on our graph. And they don't necessarily have to be in this order. I'm just putting them out there. We want the X-intercepts. Whenever we graph anything, that helps us. That's going to help us graph it. For a rational function, how do we find the X-intercepts? What part do we find where it's 0? Y is 0. Okay. What makes y 0 on a rational function? When the numerator is 0. We're finding where n of x equals 0. So we're finding where the numerator equals 0. That's going to make the function equal to 0. So when we find the x-intercepts, we can find the y-intercepts. How do we find the y-intercept of a function? What is the y-intercept? Where x equals 0 or crosses the y-axis. On the y-axis, x equals 0. So to find the y-intercept, we plug in x equals 0. And we just calculate that number. Plug in x equals 0 and we get a y value. That's where it's going to cross the y-axis. We have a rational function, so we're going to find our asymptotes. We'll find our horizontal asymptotes. We have a few rules, so depending on our rules. So for our horizontal asymptotes, we're going to use our rules. We'll compare the degree of the numerator and denominator and use our rules. We're going to find our vertical asymptotes. And how do we find those? When the denominator is 0. We find where the denominator is 0. And remember that a horizontal and vertical asymptotes are always lines. So for a horizontal asymptote, we get x equals something, and for a vertical asymptote, we get y equals something, a line, the equation of a line. When we find our vertical asymptotes, what else do we have to look out for? Holes. We find our holes. And we find our holes where? When the numerator and denominator have a common factor. So the way I usually think about it when they have a common factor is when they both equal 0 at the same time. So if they have a common factor, they're going to equal 0 at the same time. And so when that happens, we get a hole. We don't have a vertical asymptote there. So if we have a hole in our graph, we don't have a vertical asymptote at that x value. We just have a hole. And then the last thing we want to do is we will probably have to plot some additional points. Just manually calculate some points to get the shape of the graph. And where we're going to want to plot our points is between and outside the vertical asymptotes. So these are the steps that we're going to follow when we have a rational function and we want to sketch a graph. So what I want to do now is just go through the process of sketching the graph of a few rational functions. And the last one I want to do, I want to show us how we find a slant asymptote. We have a slant asymptote. So these are all things that we've done in the past. We've done all of these things before. We should know how to do each of these steps. Now we're just putting them together to make a graph. So let's do an example here. Start it over here where we use these steps. We'll start with an easy one. F of x equals x plus 1 over x. X plus 1 over x. So let's start with our our intercepts. So where would we find an x-intercept here? What's that? At -1. When the numerator is 0. So the x-intercept is x equals -1. How about a y-intercept? We plug in 0 there. What happens when we plug in 0? Undefined, so is there a y-intercept? No. What is there at x equals 0? Does 0 make the numerator and denominator 0 at the same time? So what do we have? Vertical asymptote. The denominator is 0, so we have a vertical asymptote. Horizontal asymptote. How are the degrees of the numerator and denominator related? They're both 1. They're the same. So what's our horizontal asymptote? 1. Y equals 1. The ratio of the leading coefficients. So now we can start our sketch. This is going to be a rough sketch here. I'm not going to put a grid. So the way I usually do it is sketch in my asymptotes. I usually use dotted lines just to make it clear. So our vertical asymptote is at x equals 0. So that's the y-axis. So there's my asymptote. Horizontal asymptote, y equals 1. Computers, I don't know why it's going slower than my writing, but it is. So there's my horizontal asymptote. We know that the x-intercept, I'll plot that in blue, graph by function in blue, x equals -1. So we have an x-intercept here. And then we just want to plot some points to get the shape of my graph. Now one thing to remember, our graph cannot cross the vertical asymptote. It's possible that a graph crosses a horizontal asymptote. The horizontal asymptote just tells us what happens when x gets really big. So it can cross the asymptote in here, it just eventually gets close. So it can cross a horizontal asymptote, not a vertical asymptote. So we're going to plug in some points to see what the shape is. Our function could be here, could be here, all these different places. We just want to find out what the shape is. So I'm going to plug in, I'm just going to calculate, and we just do this by plugging into our calculator, however you want to do it. F of -2, I'm just plugging in -2, and I get, when I do that, I get 0.5. So f of -2 here is up here. F of -1.5, so here, when I calculate that out, I get 0.33. So I get a point there. If I calculate f of, say, 1/2, I would get a negative number. So this tells me, and if you're not sure, just calculate more points. This tells me the graph on this side does this. And over here, I'm going to calculate some points. It can be here, or it could be here. So if I get a number less than 1, less than where my horizontal asymptote is, I know it's here. If I get a number bigger than 1, I know it's up here. So I calculate f of 1. When I plug that in, I get 2. So when I'm here, my graph is up here. So that tells me that my graph is going to look like so. And we can also use a little bit of logic here and say, on this side, could the graph be down here? If it's going to get close to this asymptote eventually? If it were down here, wouldn't it have to cross the x-axis to get close to the asymptote? So there would be another x-intercept there. So that would tell us the graph can't be down there, because it would have to cross the x-axis. So that's another clue that our graph is up here. So that would be a graph of our function. We plotted a few additional points to get the general shape of the graph. Questions on that example? And if you're not sure, after you get this information, just plug in some more points. Just plot some points so you know what your graph looks like. Just plug in x equals 2, x equals 3, x equals 1/2, and plot those points on your graph and connect them with a smooth curve. All right. Let's look at a little more complicated example. This one will have two asymptotes. So we have x minus 2 over x squared minus 2x minus 8. So what's the first thing we want to do with the rational function? When we're working with it, when we're analyzing it? Factor. We want to factor everything if we can. So can I factor that denominator? How do we factor this? X plus 2, x minus 4. So now I factor the denominator. What do we know? A couple of things that we know about the graph. Does it have any holes? No holes, because we don't have any common factors. Now it's easy to see where our zeros in the numerator and denominator are. We can start figuring some things out. So let's figure out our X-intercept. What's going to be our X-intercept? 2. X equals 2. Y-intercept, what do we do to get the Y-intercept? Plug in x equals 0. When I plug in x equals 0, I get negative 2 over negative 8. Or y equals 1/4. Vertical asymptote. Vertical asymptote is where what part is 0? Denominator. So where is our denominator equal 0? X equals negative 2, x equals positive 4. So we have 2 vertical asymptotes. That makes it just a little trickier. Horizontal asymptote. Where do we find our horizontal asymptote, or how do we find our horizontal asymptote? Compare the degrees. And how do they compare? Denominator is bigger. Denominator is x squared. Numerator is x. So our asymptotes, a few people have said it. Y equals 0. So now we have enough information to start sketching our graph. So here's my rough sketch. We have an X-intercept at 2. We have a Y-intercept at 1/4. We have a vertical asymptote at x equals -2. We have another one at x equals 4. I know my scale's not perfect here. And we have a horizontal asymptote at y equals 0. So that's the x-axis. So there's my horizontal asymptote. So my function can do various things in between here, and it could be here, 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 or here outside the vertical asymptote. So that's why we need to plot some additional points. I'm guessing that because my y-intercept is here and my x-intercept is here, that my graph is going to make kind of an S shape here. If I wasn't sure, I would plug in some points to make sure that the graph made that shape. So I plug in x equals 2, something like that, and I would end up with a point down here somewhere. So I'm going just by, because I have a little, my intuition tells me it's S-shaped. If I plug in points, that would confirm that my graph is going to do this in between the asymptotes. If you're not sure, plug in some points and calculate. So it crosses the horizontal asymptote. And out here it could be here, 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 or here. Could it cross the x-axis out here somehow? No, because our only x-intercept is at x equals 2. So really all we need to do over here is decide, is it positive or negative? Over here we decide, is it positive or negative? So I'm going to plug in f of -4. I'm just plugging in -4 here and calculating, and I get -0.375. So that tells me that over here my graph does this. So my point that I plotted is something like that. And then on this side I need to decide, is it positive or negative? I know it can't cross the axis, so I'm going to plug in f of 6. Pick easy numbers to calculate, and I get 0.25 when I calculate that out. So we're up here. So that tells me my graph does this. And my point's approximately. So that's a rough graph of my rational function. If you're not sure exactly the shape, just plug in some additional points and plot those points to get an idea of the shape. And graphs can do all kinds of strange things between the asymptotes. You could have an S shape, you could have an S shape going the other direction, you could have U shapes. Some questions on that example? All right, let's do one more, then with a slant asymptote. We'll talk about how we find a slant asymptote. For this one, we have x squared over x minus 2. All right, so we look at this one, and we see that the degree of the numerator is greater than the degree of the denominator. So we know that there's no horizontal asymptote. I'm going to write that down. None. We have no horizontal asymptote. Well, the degree is one more. The degree of the numerator is one more than the degree of the denominator. So that tells me I have a slant asymptote. So what I'm going to do here is do this division. I'm going to divide x minus 2 into x squared plus 0x plus 0. So I get an x when I do my division. And I get a 4. So this function equals x minus 2 plus 4 over, or sorry, x plus 2 over 4 over x minus 2. My slant asymptote is this part. It's this part. So I'm looking at this. The part that's up here when I do my division is my slant asymptote. Y equals x plus 2. And the reason that is because this fraction 4 over x minus 2, it's like we talked about with that homework problem. When x gets really, really, really big, this number, this fraction gets really, 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 really small. So as we get bigger and bigger and bigger, this is adding just a tiny, 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 tiny bit. And eventually, we can say it really adds nothing to the x plus 2. So y equals x plus 2 is our slant asymptote. Yes?
Is that the only time that is slant asymptote is the degree on the
One more, right. If it's more than one more, the asymptote is some other kind of curve.
so there's no constant?
Yeah, so it's some kind of curvy asymptote actually. But we're only going to deal with slant asymptotes. And you find it by doing the division. So let's find the rest of our points. We have our slant asymptote. We know we have no horizontal asymptote. How about a vertical asymptote? Where's that? X equals 2. We have the line x equals 2. We need to find our intercept. X-Intercept. What are we looking for the X-Intercept? Numerator 0 when x equals 0. Y-Intercept. We plug in x equals 0. What happens here when we plug in x equals 0? 0. So this tells us that our graph goes through the origin at 0, 0. So now we have our information. All we need is our additional points so we can sketch our graph. Oh, we're getting tight on time. Vertical asymptote, x equals 2. How do we graph this slant asymptote? You're stretching, please? You're stretching? How do we graph this slant asymptote? Y equals x plus 2. What is it? What kind of thing? It's a line. The y-intercept is, this is y equals mx plus b. The y-intercept is at 2. Our slope is 1. So we have an x-intercept of 2, slope of 1. I'm just going to sketch it in. Our slant asymptote looks like this. We know that our graph has an intercept at 0, 0. Could the graph go somewhere up in here? If it went up in here, wouldn't it have to come back and go through the x-axis again? So we know it doesn't go up in here. So our graph on this side is going to do this. Could our graph be over here? If it goes to the vertical asymptote, wouldn't it have to go through the x-axis again? Yes. Could it be over here? It would have to go through the y-axis again. So our graph goes like so. If you're not sure, plot some points. Just plug some numbers in and calculate. So this would be a sketch of our graph. All right. Homework. A good number of these problems are calculator problems and looking at the asymptotes. What is it, 48? That's a 51, sorry. All right, there you go.